everybody. After such an introduction, I've got a bit of imposter syndrome, but that seems to be the name of the game these days. Let's see if I can move on. That's me. Wojtek already discussed some of the things that I've done. And the reason why I bring this up is not just because it's a big picture myself, but couple of things I want to clarify at the outset. One is, I now work at Microsoft, but it's important to me that it's clear that this is a personal reflections on my part and not a representation of something my employer may think or not think, which is one of the reasons why I'm not using the really pretty templates that they provide for this talk, but rather did the point and click design in PowerPoint to get the slides right. Some commonalities of the work that I've done before is that a lot of it pertains to adoption challenges, getting ontologies and ontology engineering in the hands of non-academics, non-ontologists in the broader sense. So typically software developers or the like. I will speak a little bit then about some experiences from this, but I'm not going to ground these experiences in specific studies. This is more of an opinion piece, an opinionated take on what I think our community needs to do more and possibly needs to do less. And as such, I'd be happy to take this as a discussion starter for the question session. Also, having gone to industry now since recently, this is a good opportunity to sort of burn all my bridges and make myself unpopular in the community, if that's what happens. So to begin with, why do we do ontology? And this is more of a framing for my part of framing for this talk. I'm not saying that this is true for everyone. It's true for what I've done, to give you some context. And generally it is that we want to add functionality to some system, and typically that system is a software system. So we want to enable software to do something it could not do before. Of course, there are people who do ontology for other reasons, for reasons of understanding the world from an intellectual pursuit kind of way. And that's a well-worthy goal, and I have no problem with that. That has not typically been what I've done, but what I've done has rather been about, again, adding functionality to systems. And if we paint with a broad brush here and generalize a little bit, I would say that there are two main streams there. And one is the reasoning heavy side of things, trying to understand and formalize knowledge in an AI kind of way at the end of the day. And by that, I do not mean machine learning, but rather sort of the symbolic logic type AI approach, trying to understand and formalize knowledge and reason over knowledge and infer new knowledge. And then we have the data integration sort of stream. And I think that this is something this division, if you will, is quite apparent to anyone who's been in this community for some time, that people tend to gravitate towards one or the other to a more or lesser extent. For my part, I very clearly end up in the latter bin there, the data integration side of things. So what I'm going to talk about is ontology engineering with that mindset, for that purpose, integration of data from heterogeneous sources to enable functionality to software system. Because that's what I have worked with. If you are building the big next general AI agent, this may not apply to you. So then one of the first questions is, why does adoption matter here? Why is this important? Why should you listen to it? And I think when we look at how academic success, in the best of all worlds works, you work hard, you work with challenges that need to be resolved, you work at them systematically. Sometimes you have a grand vision or a piece of luck, but typically well-structured hard work over time pays off. And I'm sure this is a simplification of reality. There are many backs and forths in this, but generally on the industry side of things, there's a lot, this process is a lot more stochastic. It is a lot more dependent on immeasurable things like perceptions and uptake and networking and which technologies that win out are not necessarily always the technologies that are sort of rationally the best technologies. There are many other aspects that go into that, not least the business model and whatnot. So the question then is, why would an academic really concern themselves with industry success of whatever they're doing? Because it's sort of, from an academic point of view, I'd understand if one were thinking, this is a little bit dirty. This is not, but it is important, I think, because we don't exist in a vacuum, because we want to impact the world. We want to leave the world a little bit better. This kind of industrial opportunities can afford you evaluation opportunities of the technology that you develop in a way that you might not be able to do in purely academic settings with, a bunch of master students doing an experiment in a lab somewhere. Of course, in many cases, funding is contingent on showing the applicability of what you're doing, and grant proposals and so forth are increasingly written in collaboration with industry in one way or another. And personally, I think it's fun to actually do something that is not only sort of academic, but that might have a chance of changing the world in a little bit. Now, if we go into industry and think about what do we need in order to actually achieve this industry adoption, DevX is a developer experience. It's a term that's thrown around. And I want to clarify, I'm not a DevX kind of person. You have people who work with this, full time, developer advocates and outreach people and so forth. This is my take on it. There's a common saying that culture eats strategy for breakfast. This is one of those business truisms, which essentially means that you can, from the top of your organization, try to push out whatever your goals and your mission and vision statement are. But if they're not anchored in what the organization is actually like, what the people are actually like, that's not going to have a big effect. And when it comes to tech institutions, you typically have developer-oriented cultures. You typically have a developer-first kind of mindset. If you're a successful tech institution, you don't typically choose technology based on business cases. And sometimes you do, but typically it is based on what your devs like, and it percolates upwards. Of course, again, simplification, but a simplification with some truth to it. And there are some key criteria then in what these devs like. Now, again, this list can be made much longer if you're working with developer outreach and advocacy. Many more things go in here, but first run impressions, certainly. What does this feel like the first time I pick it up and run it? Some technology platforms have great first run impressions. I'll give you an example of that later. Easy wins and times to first success. If I want to do something that's outside of the first 5-minute tutorial of the technology, I want to do and achieve something. How long does it take for me to achieve something where I add value? We have explorability. If I want to go sort of off of the beaten track, I want to do something new, beyond the very foundational. How easy is it for me to explore the technology, the documentation? Does the way the system or programming language or whatever it may be is built naturally lead for me to take the next step? And some technologies are better at this and some are worse. Reasonable defaults, I'm sure you've heard of the idea of convention over configuration. So basically, the most common type scenario is what the system should be already a priori built for. And if you want to go and do something else, then you configure that. Evolution trajectory. I can work with a technology that's not perfect yet, as long as I can see that the people who are building it and developing it and pushing it are pushing it in a direction that makes sense to me. These are just a couple of these things, and there are many more, of course. Size of community, friendliness of community, social aspects of the community are becoming more and more important. But these are some things that I think we need to think about as a community when we try to push ontology engineering and semantics and linked data technologies into industry. And some of these things are things that industry should also, when they try to ingest what we're doing and build products out of it, of course, take into account. So here is a subset of my grievances, and my grievances could be made a much longer list if needed, but some things that I have time to pick up hopefully here. So ambiguity in basic node edge node modeling, I'll get back to that. But essentially, if you want to represent node edge node constructs in your linked data or in your graph, that actually resolves into several different logic constructs in OWL or shackle, or can resolve into, and that's a problem for us. As they say in Python, there should be one and preferably only one way of doing it right. Global fields, I'm gonna say that RDF got this wrong, and you can tell me that I got it wrong, but I'll get back to the details. Contextualizing statements, this is a little bit of a beating of a dead horse, but it is a horse that deserves to be beat. We need property graph-like constructs many times. Tooling insufficiency, I'll go over some ideas of why I think tooling needs to be better, and reusability in terms of patterns and foundational ontologies, challenges in that. So let's start with the first thing, node edge node model, right? This is, person owns car, very basic construct. And I think the person who first got me thinking about this, or persons, was probably Pascal Hitzler and Kogan Shimizu, and the work that they and others, I'm sure, did on representing, what does the edge in a visualization mean in terms of OWL logical constructs? And as it turns out, that can mean a lot of different axioms logically. On the left-hand side here, we have OWL. So the OWL owns in this little picture could be a property that has a domain and range, or you could have restrictions on person constraining what it can be used with. And actually, now that I look on it, I recognize one of those should probably be an equivalent class rather than a subclass of. But still, there's at least two different ways of representing, that there should be in my data a linkage between a person and a car called owns. Looking at shackle on the right-hand side, we have the node shape person, which has two different representations, 3 and 4 there, for that property shape edge, where one uses sh class and one uses sh node. Now, I looked into the shackle spec and I understand the difference between these two things. But the question is, how many now understand this difference? Among ontologists, probably more than among the general population, but even among ontologists, I'd say many would probably have to look it up in the spec. And if we're going to describe this to a software developer, which is it that really is the correct thing that we mean? And what are the implications of one choice or the other choice? And then think about the fact that the software that you do, whether you're using Protege or using top-grade Composer or using some other tool to build your models, how do they front this? How do they represent this? And the answer is they actually don't, not very well at all. So I need to draw the very basic construct of a person owning a car. I need to understand a lot more than I think is quite reasonable for me to understand from a developer point of view. How long would it take us to explain this to a software developer? I'm thinking, 10, 15 minutes minimum, but that's minimum, probably more, for a very foundational concept. And simply, that's not in line with this first experience that I spoke of earlier. So this is one problem for us. Global fields. This is where I tell you that RDF got things wrong, and you can tell me that I'm an idiot. So person has family name, and family name is string, right? Most cases when we do data modeling with developers, we're not interested in, but we do type first, right? So we describe the person type, and we describe the data that is according to the person type. And that has fields on it. And those fields can be, data properties or object properties. From my point of view right now, that's irrelevant. But the type is a very foundational concept. And in RDF, those fields have global identity. And very often, as a consequence of that, they also have global semantics. And that's typically not needed. Most data modeling cases, you want to describe your type. You do not want to state that family name is a generic property that applies to anything, anywhere that you can apply family name to. You want to describe family name in the context of person specifically. So why is global field semantics, as I call it then, bad? Because some names are very common, but are semantically ambiguous. I've exemplified with some here. So sometimes name have actually completely different semantics. And if you sort of use that IRI, then it's used, right? Other cases, the name may be mean roughly the same thing, but you may want to specialize it a little bit depending on where in the hierarchy or where in your model you're using it. So parthood, for instance, you may want to say that a certain type of thing, equipment, can only have other equipment as part, whereas organizations can only have other organizations as part. So you want to express locally some constraints on the semantics. Now, of course, you can do this. You can establish your properties globally, give them global identifiers, and then only use local semantics. So what I mean by that is you can design your object properties or your data properties centrally. If you're using Shackle, you only then use them with property shapes that are attached to node shapes. You don't use any RDFS domain or range declarations. And similarly, in the OWL world, you would not use domain and range, you would only use restrictions to locally define the meaning of these terms. But the question is why? Why then would you do that? What's the value if you give a global identifier but a local meaning? This is, I think, a problem because you typically end up in this case that you want to reuse these things, and the names are already taken or mean something else. I'm gonna have to jump across there. Next thing, this is the dead horse I was speaking about that I'm beating again here. Statement level metadata. This occurs again and again and again, that you need to say something about a statement that is about a relation that is true for a certain time, for instance, or with a certain confidence or what have you. And sometimes there are ways of naturally reifying this. So you could use, you could create, typically you could create a role. If you have a person and they're doing something for a certain time, you'd reify that, you'd create a role in between and whatnot. Common design pattern. Other times that does not make sense. So something that we've come across in representing buildings is you want to say that there's this piece of equipment here that feeds this other piece of equipment, something. And you want to express the feeds relationship, but you also want to be able to say that this feeds is of a certain substance. Could be natural gas, or could be water, could be air, could be whatever. Now, my users, they do not want to go all the way to building a huge ontology of all kinds of piping and plumbing. That's not what they're interested in. They just want to be able to say, logically abstract, that my HVAC unit feeds my VAV unit air. And there's no nice way of doing that using Shackle and OWL at the moment. Of course, we have RDF star that's coming along nicely, or we don't have it yet, but hopefully we'll soon have it as a standard. And I'm not sure how that will actually work with Shackle or OWL. I've seen some threads on this Googling around, but I've seen no suggestions whatsoever on how to front this in a user experience and a developer experience type tooling so people can actually use it. So this is a challenge for us. Property graph style constructs are often needed in the real world, and we need to get better at describing this and supporting this. Tooling challenges, yeah. We have a whole bunch of tools. We have IDEs, Protege, TopGrade, etc. We have visualizations, we have documentation generations, we have data stores, so triple stores, and all of these things, a bunch of these things. But they are typically disjointed, typically built one at a time, piecemeal, not at all integrated. If they are nicely integrated, they're typically a commercial offering that costs a lot of money. And fair enough, it's an open market. But I think this is somewhere where the academic community could work to deliver a better experience for developers. And the question here, how long to value creation? This is, if I need to not only sell to a developer that they should use semantic technologies, but they should use this and that and this and that and that tool, and they should configure them, and they should learn how to shift data between them. It's not a very holistic experience. It's not a very nice and smooth experience. Now, keep in mind, these developers that I've been talking to, I mean, I worked with people who have 15 plus years of software development at large companies. And it's taking them long time, months, quarters of years to actually properly understand how to get the toolchain put together. And these are not stupid people. These are people who are developers at large companies who worked for a long time with development, but they don't have the time to sit down and take the master level course in ontologies and semantic web. And so this needs to be more intuitive. Oh, I'm going to show you something that is intuitive. This is from a bit of a competitor, I guess, from my company. This is Neo4j. And I know that Neo4j does not have expressive semantics in the same way that, Shackle or OWL or these things. They have a comparatively simple data schemas. But if you launch the Neo4j product and play around with it, you'll see that, you have visualization immediately, you have a query language immediately, you have, let's see, what was the next thing? You have this data integration wizard that allows you to map incoming tabular data into graph representation. You have all of these things, and they're tightly and nicely interconnected, integrated, and work together. And you can spin them up within, 90 seconds or something, or a couple of minutes of clicking through a couple of wizards, and boom, it's there. Now, immediately understandable. So what we need are tools where I think ontology and data graphs are actually integrated and working together, right? I think we need tools where the GUIs are integrated and working together, as opposed to separate experiences where you run one in your terminal over there and one is in your protege over there and whatnot. We need workflow integration. So I shouldn't have to copy this file over here somewhere and perhaps then upload something into a GitHub and then perhaps add something to an indexing database over there, whatnot. And all of this needs to work across teams with multiple people. So I'm talking about essentially a commercial product here. I recognize that I'm talking about a commercial product here, and that's a challenge that I'll come back to. And then the reuse challenges, perhaps most relevant for this community, which is ontology design patterns or foundational ontologies or what have you. They need to be large enough chunks of functionality to not be obvious. So design patterns consisting of, two classes and one relationship. That, if I bring that up to someone and say, this is how you should think about it, I mean, there may be a lot of thought behind it, and this may be part of a larger whole, but then in that case, the larger whole is not properly displayed, and it is too small to actually convince people of the value of this reuse. On the other hand, if we go the other side with the foundational ontologies, you have enormous ontological commitment and overcommitment. I'm going to throw some examples in here that I think are good at balancing this, and I recognize this is a balancing act and an opinion piece, but the analysis patterns in Martin Fowler's book by the same name, obviously. The BOT, the building topology ontology, I think is a nice size model. FOF, not necessarily, and I'm not talking about the quality of these, mind you, I'm talking about their size being roughly appropriate. It is important, I think, and this is something that I myself have turned around on, the important is not the serialization into OWL or Shackle or what have you, not the reusable building block that you throw into your tool and run. I think if I would have listened again to Pascal Hitzler a long time ago on this, I would probably have been a wiser person. The important thing is the meaning that you are trying to convey. And that may be typically through diagrams rather than logic formalisms. Logic formalisms come later. So in the end, serialization doesn't matter. Conveying meaning matters for reuse of ontology blocks. Which is why, given what I told you about the shortcomings of RDF, Shackle, and OWL, you may want to consider using something else entirely. I recognize I'm running a little short on time, so I'll try to be brief on the closing slides. I'm going to show you something here. This is a Microsoft language, Microsoft technology called DTDL. I'm not proposing that you go and drop everything and go and buy DTDL, because it's not even something you can buy, by the way, but it's a modeling language that addresses some of these challenges. There are other languages out there, other approaches to modeling that solve it in a similar manner. DTDL has its warts as well. This is just what I'm most familiar with at the moment. But if you look at the W3C Web of Things description, for instance, you have something along those lines. And many of these sort of developer-oriented languages also veer towards this. So what we're looking at here is, on the left-hand side, an interface, or essentially a class, and it has contents, which are properties or relationships. On the right-hand side is another class. And they can extend from one another. So on the top right there, you have that conference room extends room. So the right-hand class extends the left-hand class. And within the contents block, you then have sort of the defining characteristics in terms of properties and relationships to other things. Let's see if I can give you a graphic overview of the language. Oh, there we go. Something like this. So you have your interfaces, which can extend one another. So those would be equivalent to node shapes or OWL classes in Shackle or OWL. And they have all these things within them. Relationships, properties, telemetry, command are typically, because this is from the IoT space. But for now, let's just talk about properties and relationships and components, which are reusable, if you will, nested schemas. And your properties can have, primitive schemas, strings, integers, whatnot, or maps, or objects, or enum schemas. And your relationships have targets that are other interfaces. And that's really it. It's very simple little language. What does this do to solve what I spoke of before? Well, if you look at one, the node-edge-node construct. The node-edge-node construct is a relationship. There's no ambiguity. There's only one way of representing that two nodes should be able to be connected by an edge, and that is via the relationship. The two here, the local field. Fields don't have global identity. Fields have identity in relationship to the class that they're defined on. So capacity on this conference room is a local field. Now, if I want to get fancy, I can actually add a global IRI for those cases where that's necessary, but that's very rare, I find. And three, we do have actually the opportunity to express for a relationship that there are properties on relationships. So I could, to this relationship booking responsible here, I could add properties such as time duration or whatnot as a nested subfield. I argue that putting this kind of much simpler language in the hands of developers, which we've done quite a lot of, they pick this up, they grok it, they start working with it. It works for solving their problems for the data integration challenge a lot faster than my experience of using Shackle and OWL. It has a small subset of the expressivity of Shackle and OWL, obviously, but it is enough. And I think that's sort of one lesson here, is that if we're doing the data integration work and we want to see adoption, we perhaps need to relax our ambitions a little bit and focus on the data integration challenge. And that's perhaps also the other lesson, is that if we're trying to solve two problems, the general knowledge representation problem and the data integration challenge, using the same kind of tools, then we're not going to be good at either of it. There are some open challenges resulting from this here, and this is about towards the end of it. So these anecdotes that I presented about local fields and about property schemas and about ambiguity in node-edge-node constructs, these experiences that I have now from several years actually of ontology engineering, are they actually real, or are they just my anecdotes? Well, I would propose that for this to be academically viable, you should probably do user studies. And I mean properly user studies, not just with the 5 students that happen to be available, which is how we typically do things, myself included. So I think the community needs to take a step back and actually evaluate and do proper user studies of the technologies that we do. And I don't mean only this community, but the broader semantics community. Secondly, I think we do need to look into patterns or foundational ontologies and look at them and study and evaluate them instead of just pumping out new ones. I think we need to look into and evaluate those patterns and ontologies and their feasibility and their characteristics and their qualities in a structured academic way. And then once we know what is good and what isn't good, either refactor what we already have or create a new things that are good per whatever that definition is, for whatever that use case may be. And thirdly, of course, the tooling development. And there are 2 challenges here. One is, of course, the cost of building something qualitative, which is why, again, this is almost a software engineering or rather a product development point of view. I recognize this is difficult in academia. And the second thing is the longevity of maintenance. Once you've built something like this, if you build it, you need to support it. You can't just let it out into the community and then go to your next grant proposal and it dies after 3 years. We've seen plenty of those things. And that does not give us trustworthiness when we communicate with industry stakeholders. Let's see, I think that's all I have to say for now. I'd be happy to discuss all of these things now and or later, but that's all for now.
Yeah, Karol, thanks a lot for a great talk. I think it will let us contemplate for quite long and hopefully make some action.
Oh, and thank you. That's the intent.
Yeah, so I'm just checking if there are any real questions. There were some comments certainly in the chat, but I'm not sure if any of this is questions. So if anybody considers this as a question, please say directly to Karol. And if there are any other questions, so just either start talking or raise a hand as you prefer.
I see Rink writing about this is actually a call to action to the startup community, and rather than the academic community, or not only the startup, but also ISWC can hardly be called a startup, I guess. Yet someone needs to do this. I'm not, who does it? Well, that's a business and a program management kind of challenge. I think it is important that this kind of thing exists. I think it would be beneficial if it were licensed in such a way as to be palatable to academics and startups, rather than as a closed source commercial product. Who does it is perhaps less important than the fact that something like that exists. And I do think that the building of a community around that sort of thing to further long-term viability is also crucial.
Okay, more questions? I might actually have a general one. Maybe it was somewhere between the lines, but you were talking about the grievances you have, and I'm just wondering. I can figure out which of them are just a matter of mildly changing our style of thinking and practice, and which of these means really something that's inherent in the concept of the RDF-based semantic web and needs a major change. Like, for example, moving to RDF star, there's something that needs a new standard, a new implementation, and so on, right? So how many such major challenges which need a big changes are there, and which are just something that we think differently and mildly change our practice?
So I think I would suggest that going towards local field semantics requires dropping, or depends on going to shackle as opposed to OWL. I mean, you can do it again with restrictions in OWL, but it is ugly and messy, and ugly in the sense that, not logically ugly, but ugly in the sense that it's hard to communicate, it's hard to understand. Whereas Shackle has that sort of built in, essentially, that you can just skip the domain and range declarations and use local semantics, even though you then may have global identifiers, but their meaning is defined locally. Their semantics is defined locally in the property shapes and node shapes. So I think that's probably not a breaking change so much as a change in terms of practice. Let's see, node edge node modeling. I suppose that is something that you could achieve by simply having a more opinionated set of tools. The fact that the language allows you to do many things, but the tools propose and very clearly push users towards doing the reasonable thing. I suppose that's okay. Challenge there, of course, being is that if I build my tool and someone comes from the side saying, here's my graph that I built using something that's not consistent with these recommendations, and then I'm not formally, my tool can't process that or visualize that or present that or do something with that, then I'm going to have an unsatisfied user, which is also bad for adoption. I think one thing I didn't touch upon here, but which I think is also absolutely crucial, is documentation and tutorials and guidance. I mean, I can read and appreciate the W3C spec docs, but it took me 10 plus years to learn how to do that. And I don't think we should expect developers to do that. Let's see, Rinke, you have your hand up.
Yeah, so thank you for the talk. I come also being moved to industry myself 5 years ago. I had similar experiences. I also share some of the problems that you I shared. Those are problems, but I really disagree with some of the solutions. But it's a longer discussion, though. I think my main point is that yes, this kind of tooling or the languages that we use may not be very suitable for developers, right? And that's perhaps just because developers are really good at developing stuff, and we're really good at ontology engineering and knowledge representation stuff, right? So some things are complex for a reason, right? And all of these things, the features of the languages that we have at our disposal are all developed with a certain reason in mind. Sure, they're not all perfect, and there are some things where it should have been different. Of course, there's always things like that, but these are just different. If you're talking about a professional organization in industry, you just have different roles. So there's people who are, maybe it's this knowledge scientist that Paul Groth and Juan Sequeira came up with. Maybe it's more like a data engineer with an extra benefits. But it's just not the run-of-the-mill developer that you want to point at top rate, because that doesn't really make sense. They have another job to do. That said, I think there's a great many things to say for translating between different formalisms, right? Having a JSON schema representation of your ontology makes a lot of sense for API generation, those kinds of tooling. But I think those are more in the translation between the different worlds than in changing our languages, because our languages are there for a reason, and I think they're good.
I think I'll go back to the caveat that I started with, which is, for the data integration point of view, this is what I worked most with. If we're talking general purpose knowledge engineering for other purposes than integrating heterogeneous data, then I can certainly say there are other considerations at play. But when I speak with software developers who build systems to essentially mash data together from, well, say IoT, common scenario for me these days to work with, they are developers, software developers first and foremost, and they're close enough to these, because these are all pipelines where data flows through multiple stages, through multiple systems, and end up in a time series database somewhere and whatnot. And it's not only going to be knowledge engineers that are touched by the schema of this data. So it's going to be software developers that work with this on a daily basis to achieve value. And if the schemas do not support what they need to be able to do, then there's a problem, and then they need to get involved in the ontology engineering as well. They're not going to be knowledge engineers in that sense, but I could certainly envisage them firing up a tool and saying, okay, we need to shift these things a little bit because that makes the most sense from the domain that we're working with, and need to be able to understand the implications of shifting those things. So maybe not the class of user you're talking about, but what I'm proposing is that this class of user exists and don't have their needs met.
Okay, maybe. I'll leave time for Chris. We can take things offline.
Yeah, absolutely.
Yeah,
I'd love to continue. Yeah, Chris.
Right, can you hear me?
Yeah, absolutely.
Okay, cool. So I would like to follow up on a topic that Rinke just raised, and that is, first of all, I think that you're absolutely right that we would like to work towards adoption of semantic technologies in general and all that. And there are obviously some challenges and problems and all that. But then Rinke has the fair point that we do have a bunch of tools and we do have a bunch of technologies that we use and actually work with. So now my question is, how, or do you already have an idea of how to evaluate the tools that we have and the patterns that we have produced in order to facilitate their adoption, or to understand what works and what doesn't, or what works or doesn't work for certain users?
So I have opinions, whether they are grounded in or can be validated across a larger user set than just myself is, questionable. But I think one thing is the integration of data and schema. For when you're working with this, you do not want to have an ontology engineering environment over there and your data store over there, and then try to move things back and forth through manual or automated processes at intervals to see, does this work? But it needs to be a more holistic experience is one thing that I think. I think that, let's see, I put some notes. What was I going to say more there? Sorry, I lost track of my thinking there. But that's certainly one thing. Sorry, I just had a complete zoned out there. If this happens.
Yeah, no worries. I was just really interested in this idea of taking what we have produced so far and trying to understand how we can.
So it was actually one thing I was going to say, which I think is difficult also here, is building of community. And this is one of those tricky things. Are we talking about outside of the academic community exists, right? I know several of the people on this call already through academic channels, met at conferences and whatnot. There's a certain degree of trust there because you've spoken to one another over a long enough time and you know that the other people know what they're about and all of that, right? And it becomes a bit inbred. And if one wants to build something that goes outside of this scope, that actually is accessible to developers outside of this group, then one needs to build a community that invites those people. And that is something that I found extraordinarily challenging, to get people on board and build open source type software communities. I mean, I'm amazed by how these large open source projects actually work. It's amazing. We have comparatively few such communities within the academic, sub-communities within the academic community. It is typically driven by one research group or a couple of research groups in collaboration. And when funding runs out, then you move on to the next thing. So building of a community that stands the test of time, however one does that, I think that's a huge challenge for developing this tooling kit. What else was I going to say there? No, it's no, I think that's one of those two things.
Yeah, that makes a lot of sense to me. Thank you.
And then we have the evaluation of whether things work or not. To what degree, what's useful or not. I think, again, I think proper user studies here are needed. I think that's difficult for computer scientists to do. I think that if you come from a sort of social sciences kind of background, you're probably more well suited to that kind of evaluation, generally speaking, than if you come from engineering and technology. but I think we need people that cross those boundaries. And I think we need spaces for that within the semantic web research community. So definitely, and perhaps this workshop, if it's not only about ontology design patterns, but also about ontology engineering in the broader sense, which is the direction recently, I think could be one venue where such work is supported and promoted, evaluation of ontology engineering tools and practices.